Hi and welcome to finding the nth term rule for a quadratic sequence with Mrs. Kirby. Now, a quadratic sequence is a sequence that has n squared in the algebra that describes it. So we start off by looking at our sequence and working out the difference between each term. So in order to get from 7 to 9, I have to add 2. To get from 9 to 13, I have to add 4. From 13 to 19, I have to add 6, and from 19 to 27, I have to add 8. That is the first difference between the terms, and that is not constant, it is changing, which means we need to look at the second difference. So the difference between 2 and 4 is add 2. The difference between 4 and 6 is also add 2. The difference between 6 and 8 is also add 2. This is the second difference between the terms, and this is a constant. So what that means is we take this second difference, we halve it. It always halves, it's not just because this number is 2, we always halve it, and that will give us 1. And that tells us the coefficient of x squared. So the number that goes in front of the x squared, or in this case, the n squared. And that means we've just got 1n squared, or just n squared. Okay, so I'm going to highlight that because that's part of our sequence. We then need to go back to, let me just change that, I don't want n squared, x squared there. We need to go back to a table where we look at the sequence, the position of the sequence, which is the n number, 1, 2, 3 and 4. So this is the first term, n equals 1, the second term, n equals 2, the third term, n equals 3, and the fourth term, n equals 4. Then we look at what n squared is, because I've already decided that I've just got one lot of n squared. 1, 4, 9 and 16. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Then I fill in my original sequence, which was 7, 9, 13 and 19. And then I always draw another line here so I can make sure that I have my new sequence separate from all of the other numbers, so I can keep track of where those numbers are. Then I look at how I get from 1 to 7, and I just have to add 6. How do I get from 4 to 9? I add 5. How do I get from 9 to 13? I add 4. And how do I get from 16 to 19? I add 3. So this is my new sequence here that I'm going to find a rule for. So let's write it out like we would if we were working out the rule for a normal linear sequence. 6, 5, 4, 3. We look at the difference between each term, which is minus 1, minus 1, minus 1. That tells us minus 1n is in the formula, or you can just write minus n, that's totally fine. And then to find the number bit that goes on the end, remember that you do the opposite of minus 1 to the first term, which in this case is add 1, and that would take us to 7, which is positive, so it would be minus n plus 7 would be the rule for that part of the sequence. So I'm going to highlight that as well, and then we're going to put the two highlighted things together to find the whole rule for the quadratic sequence. So we've got the orange bit, which is n squared, and then we've got the purple bit, which is minus n plus 7, and that is the rule for the sequence which we started off with and you can just see it at the top there, the 7, 9, 13, 19, n squared minus n plus 7.